Okay, so object-oriented design and modeling using UML. Under this, we are going to focus more on the design aspects of object-oriented. So as you know, in our earlier classes, we have been focusing more on object-oriented analysis, where you capture the conceptual information from the customer in terms of the use case diagrams, and we get a basic idea of how the system is going to work and how the users are going to use the system. In object-oriented design, our main focus is on more of the implementation details, how this conceptual design can towards a idea behind OOD. Okay. So simple definition. OOD is an approach used to specify the software solution in terms of collaborating objects, their attributes, and their methods. So collaborating objects means objects talking to each other, calling each other. How do objects call each other? They call each other through their respective methods. For example, you have object A calling object B. Object A will call the method in object B. Similarly, if object B wants to talk back to another object called C, he will call that object in B will be calling the methods defined in the or attributes. Attributes means the properties. So OOD is a way of making the objects talk to each other or send messages to each other, or in other terms, collaborating with each other through their respective attributes and their methods. So we have learned, I think, briefly, class diagram is a way where you define these attributes and methods for each object. So class, we represent it in a UML class. So there are different types of classes which you can derive from a use case diagram. The one such type is entity class, an object-oriented class that contains business-related information and implements the analysis classes. They correspond to items in real life and contain information known as attributes that describe the different instance of the entity. Okay, so entity class is a class which will hold information about business objects. Now in your domain, you have a lot of business objects, right? Those will be represented as entities. So we note them as entity classes in the UML diagram, which is responsible for the business logic and things. Then you have boundary classes, or we call them interface class. Now, interface class is a class to understand in a very simple term is, now I think in the first lecture we learned, now you can take this example of a TV as a main object. We are the user, that's another object. Now I want to invoke the operations on the TV. I can either directly go and interact with the TV through the button interface. So there are buttons there where to switch on, I have to go through that button. So that button is exposing an interface. Basically, it's an interface function. The volume increasing, decreasing, all are on the TV. So that's one way. Another type of interface will through a remote. So the remote will serve as an interface to the TV. So in that case, that middle part where the remote control is called, you can define that remote control interface class. Like that in that washing machine scenario also I explained. So you have the washing machine. So if you want to do some operations on the washing machine, you have these knobs and buttons. So these are some examples of interface class. Like this, if you take any scenario, any business-oriented application, you will identify certain classes doing this kind of a behavior. Now, for example, application, if you are going to include payment, payment processing, credit card processing, then you have to introduce, so you have a third-party system like from a bank, from a commercial bank or some business-oriented bank is providing you all the methods that need to do the processing or to do the transaction. But for your application to talk to their particular functions, they have to give you an interface, which is called a payment gateway. That's an important term here. So payment gateway. So payment gateway will serve as an interface for your application to be able to connect to the other party. So any class that behaves in this way is called interface class. So an object class that provides the means by which an actor means we, the users, can interface with the system. So more internally also we'll see a lot of interface classes into the system, such as a window, which you design in your software, a message box, dialog box, or the screen, right? So these are examples of object. So the responsibility of an interface class is twofold. One is translates the user's input into information that the system can understand and use to process the business event. So it takes the user input and that is one thing. Then takes data pertaining to a business event and translates the data for appropriate presentation to the user. So both ways it will handle, right? If you have, for example, if you have two objects, so object to object B, interface class will facilitate that. And object B wants to talk back to object A. If he wants to send some information back, then also you will have a interface class that is going to serve. Then you have control classes, another category of class diagrams. An object class that contains application logic, implements the business logic or business rules of the system, sending and receiving messages from the entity class. Okay. So what is this control class? So how is it different from entity class? So what did we learn under entity class? Entity class contains business related information, or like it represents a object, or let's say the main informations we are storing in the database, they can be represented as entity classes. Now, for example, in your books example, there is a member ordering system, member registration. So there, member is an important thing that you store in the database. Order is a main important thing. So that main important thing is called an entity. So that is entity. So it will simply have information about, like, for example, if you want to get a member's name, so there will be a business logic to get the member's name. Then there might be a method to, change last name or update first name, last name. So that is going to do the logic attribute of that entity. Similarly for all the other entities. But here in control class, we are talking about business rules. Now with the member, how do we identify whether he is a registered member or non-registered member? Whether this person can have facilities to certain things or not, whether he is an eligible person. Like that, you will have a lot of business rules. All those business rules will be implemented in control classes. So you have at one end the interface class. Then from the interface class, through the interface class, it will communicate with the control class. Then control class will then again talk to the persistent class. I think the next one is the persistent class. So if I just correctly put them down after learning this, I'll show you the hierarchy, like how the things will communicate. So persistent class is something directly related to the database. So how do you talk to the different types of databases you have, right? An object class that provides functionality, the functionality could be built into the entity classes. But if that functionality is put into a separate persistent class, the entity classes are kept implementation independent. So generally, if you are using only one database, sometimes you don't have to think about a separate persistent class. You can directly have all the database connectivity logic into the entity class itself. Because now, for example, get member name. So you can have that method there in get member name and directly connect to the relevant database. But imagine in a scenario in future you want to migrate your database, you want to change to some different version of, let's say, MySQL or something. In that case, if you want to so different databases have different connectors. You might have learned about ODBC connector, JDBC connector, MySQL connector and all. There are different connectors, right? So if you want to change that, it will be very difficult if you have it all in the entity class. So in that case, if you have separate persistent classes, you don't have to worry about updating the entity class. You can touch only a persistent class, or you can just implement a new persistent class of how to connect to this new database. You only worry about that. You don't have to worry about changing your existing code. So let me put this into a let me show you how the organization, how it is arranged generally in a UML, or how you should understand as part of a system. Let me show it in. Okay. Insert a couple of shapes here. Right. So here you have. So again, I would like to recall that in case for this type of subject, it's better to have a paper and note with you. Sometimes it will be better if you learn on the go. Obviously, you can even come back to the video and have a look at it. But like when you do something physically for yourself, it will be much more productive as well. If you don't have now, no worries. But maybe in the next class, better have it with you. Okay, so this is going to be your entity class. Okay, what happened to that? Entity class. This is going to be your interface class. This is going to be your right. And this is going to be persistence class. So when we use this word class, it will be a programming class that you're going to use in any language, any object-oriented language. Now in Java, it will be a Java class. So these are all Java classes, separate Java classes with their respective names. Here I have used only the type of it, type name, but you will be using something related to that. For example, if it's a student thing, so that will be a student class, but you have the type indicated in the UML diagram as this is an entity, this is an interface, this is a control, something like that. So an entity class can have access to multiple interfaces. An interface can also have access to multiple classes. Similarly, now persistent class can have access to many control classes, no issues, but a persistent class will be connected to only a single database. So I will show the database separately like this. So for example, this could be SQL, MS SQL Server, or maybe in the future, since the trend is like that, you may go to a NoSQL database, which you have to learn in the future. Any kind of NoSQL is a general term. So there are like MariaDB, CassandraDB, MongoDB. Those are all NoSQL cases. So this is how the interaction would be. So I'll just show you the association lines. Something like this. Right. Let's do that. Hold on, I'll get back to your question. Let me keep it simple. Yeah, I'll remove it. Before I go to the explanation again, what's the question? If we don't need a persistent class, so that entity will connect through a database. No, you can avoid persistent class. I mean, in which case you should avoid this if you are 100% sure your application is not going to use any other different database. Then instead of having the connectivity logic here, you can sometimes have it with the entity class and some part of it under the control class. More or less, it will be defined. The connection string, all those things will come from here. Like for MySQL, connecting to MySQL, all your connection related parameters, all those will be defined in the entity class, and then you will go and connect it through the control class to the database. The control class will not have the information about which database you're connecting on. All that will come from entity class. Since that is not a good design, it's always a separation of concerns. That means, and also there is another thing called single responsibility principle. What single responsibility principle says is each and every unit of code or unit of functionality should be doing only one particular thing. It should be responsible for only one thing. For example, if we are having an interface class responsibility is only to provide the connectivity to entity class and the control class, not anything else. If you take there only you will go and change any new business rules, let's say new type of bonus calculations are coming, for example, in a employee scenario, for example, in a HR system. Then you don't have to touch any of these other classes. You have to just go to the control class and at that logic, and then accordingly you just have to provide the interface externally. That's how it will work. Now that's how, if you think of most of the mobile applications and online, now most of the time you don't update your software. Early days you had to completely download the software each and every time when there's an update. Nowadays that doesn't happen. Most of the new things are provided from the server itself, because they have this control class, persistent classes on their end. Without touching the front end, they just keep updating this part, the bottom part, right? That's the reason. So hope did you understand my answer? Okay. So others, any questions on this? So in this particular thing, persistent class, you can see, so persistent class, I have only made one connection here, right? Assuming this application will only connect to MySQL. Now, if I'm going to introduce another database, I have to have a NoSQL, for example, NoSQL DB is connected. I have to create having all the connection string or database related information or logic in that class, which is supportive to this one, right? And in this case, you can see I'm not going to update anything. I don't have to worry about any of my other logic. Easily, I can just update this logic and include a new class and make the application work. So this is the beauty of object-oriented design, right? You separate everything as separate objects and tackle the. Okay, so how about others? I assume you understood. Right. Okay, let's proceed. So that's persistence class. Okay, there is another one that goes system. Now there might be certain classes in your application where you directly talk to the operating system level, right? You want to access the hardware, you want to do certain things with the services, system services, utilities, right, which you see in the task manager and all. So to talk to those different services in the OS or the different hardware devices, you may have to define another level of it might be coming somewhere here at this level after another class for the system level operations. Now, one good example is in .NET framework, we have this Windows 32 API classes. There is a separate library for that. So that is basically, in other words, called system classes. So those kind of things you can define under system classes, and in your UML diagram also you can highlight that as a system class. So mostly this kind of question might come in an MCQ section of your. So an object class that handles operating system speed function. If the system is ported to another system, only the system classes and perhaps the interfaces have to be changed. So just as I explained. So if you have targeted Windows operating system and you have a system class that talks to certain hardware and Windows, if you are switching to Linux or Apple OS, so Mac OS, you have to change that system, or you have to include a new system class that supports that, and not to worry about any of the other logic. So any system design you are doing in your applications, you have to, it's a good practice to follow these separate ideas. Object-oriented design is the most common object relationships. In object-oriented design, we focus on modeling more advanced relationships in order to accurately specify the software components, right? So in the early stages, what we do is we just try to find the basic relationships between the objects Now on the design, object-oriented design, we go into more detailed information of, as you saw, maybe earlier it was a single class, but now you have split it into multiple classes and you understand between the different internal relationships or different parts of the software. Dependency relationship is used to model the association between two classes in two instances to indicate that when a change occurs in one class, it may affect the other class. So we show that through a dependency relationship. To indicate the association between a persistent class and an interface class. So mostly that could also happen. Now, in this case, if you look at this, place new order handler. So order handler depends on this particular class, right? So if something changes in this class, it's going to affect the window also, the window interface. So that's how you have to understand this. So this one is dependent on this. Yeah. Is that correct? Or is it the other way around? If you do an interface, place order handler also changes. How do you read this dependency? Do you remember dependency relationships? Forgot? Let's quickly revisit notes. So these details are very important MCQ and also the part 2. And see. Yeah. So, for example, if you quickly see here, suppose you're designing a system that displays corporate forms on screen, so employees can fill. This is a menu to select the form to fill out. In your design, you have a system class and a form class. Among its many operations, the system class has display form. The form the system displays obviously depends on which form the user selects. The UML notation for this is a dashed line with an arrow head pointing at the class dependent on. Okay, so system class depends on form class. Get the point? So the way we show the dependencies when some object is depending on something else. So here, if this person changes, you have to update this person. So similarly, in our example, when we say order display window depends on place new order handler, that means if something changes here, you have to update the interface. Now that's clear. Illustrated with an arrowhead pointing only to the direction a message can be sent. So in UML, you can specify the arrow and say this is the side the information is going to go. By default, associations between classes are bidirectional. So if you just put a dashed line, that means it talks both sides. However, there may be times when you want to limit the message sending to only one direction. In that case, you just show a arrow mark with the message. Another thing we define in our class diagrams. So the level of access an external object has to an attribute or method. So there are things called public, protected, private. I assume you have already learned this on the introduction, or sorry, programming 1 and Java. What is public, what is private, what is protected and all. So those things, how do you show it in your UML diagram is through these indicators. So you put this plus mark. So if it's a public attribute, you put send the attribute name. If it's a private method related to any class minus, say for example, member name. So that might be a private variable. Then private variables will be manipulated through public or private methods. So again, those things you have to put this prefix. So the meanings of what is public, protected, private, just like in your programming language. So because now we are talking about object-oriented design, because this design is the one, this design document is going to be handed over to the development team, the system software developers. So that's why we use these notations. So public attributes can be accessed and public methods can be invoked by any other method in any other class. So it's like a global thing. Protected attributes can be accessed and protected methods can be invoked by any method in the class in which the attribute or method is defined or in subclasses of that class. So I hope that is also clear. So public is if you have attribute or method defined as public in class A, classes, right? That is what is called public attributes, public methods. Protected attributes, protected method means you can only access those attributes and methods within that class or the subclasses. For example, you have a animal class as a superclass, and it has certain let's say attributes. One or two attributes are defined as protected. Now, if you want to access those attributes, use them or the subclasses. Like for example, if you create a dog class or a cat class out of that animal class, you can access those protected attributes only on those subclasses. No any external class, like for example, if there is a completely different human class cannot access the protected attributes of animal class. That is the meaning why it's called protected. Right? It can be accessed only within it or within the subclasses. Outside. Right? Private attributes can be accessed and private methods can be invoked only by any method, only within that class only, not even in the subclasses. Right? So it can be accessed and private methods can be invoked only by any method in the class in which the attribute or method is defined. Okay. If a method needs to be invoked in response to a message sent by another class, the method should be declared public. Now, this is answering the question, when can you use public? When it has to be invoked in response to a class, the method should be declared public. Now, take that example, class A wants to get some information from class B. So class B should have a method that is public where class A can call it. That's the meaning. In most cases, all attributes should be declared private to enforce encapsulation. So the good design is you don't make the attributes public, you have to make them private, and you have to provide access to this through the asking street name. The easiest way is to make this property public, but that is going to introduce a lot of other problems, and it also violates this object-oriented principle called encapsulation, data hiding. So we should always keep our attributes to ourselves. That's understanding the different term. That is what we have to say. Our attributes, let's say if we are a class, we have to have our attributes kind of private, and through the methods only we have to show. Imagine, in another analogy, I can explain this. Now, you may have a, let's say, a name for a person within your house, right? So, imagine your house is your class, and like there's a person, and you may use a particular name to call that person, some nickname, right? But when you are allowing others to call that person, you may not accept to use the nickname. You may have to ask them to select the real name of the person. Right? So in that case, you can see we control what needs to be told to the outside, or what needs to be accessed to the outside. So this is how data hiding works, or this is concept of encapsulation. So if you have a class, your attributes are always going to be private to you. And if somebody else wants to call and get some information, you can add that logic into a public method and return your name here. You can even change it in a professional way and display it out. For example, maybe street might be here in all simple letters. That is because privately you are okay with that. But when you are going to display that into a screen, you may need to give it in a nicely formatted way, maybe with the comma separators, everything. So all that logic can be included into the that particular method, and then when a external object is calling, it will get the relevant information. Point, was that clear? Why the attribute should be private and how it should be accessed. If somebody wants to access, it should be public. Okay. Cool. So I assume even P, or whether it is Java, C#, any object, when you are going to create a class and you are going to introduce attributes, don't even think about making it public. Always make it private. And then if you want to allow that thing to be gone outside, put it into a public method and make it accessible for other objects. So this is the general rule behind object-oriented programming. Okay. Object responsibilities. The obligation that an object has to provide a service when requested. Thus, collaborate with other objects to satisfy related to the concept of being able to send. It should be send, S-E-N-D, send and or respond to messages. So generally, when an object is there is a responsibility that object takes. So when that object is called upon or asked for information, it has to provide. That is the general nature of an object. Thus, collaborate with other objects to satisfy the request if required. So mostly it's about message handling. So when somebody else is asking something, the ability to respond back is an responsibility of a object. So object-oriented analysis, we define and identify objects based on the ideal conditions. In object-oriented design, we refine. Refine means further fine-tune. We tune further and make the use cases and objects to reflect the actual environment of the proposed solution. As I told earlier, here it is in object-oriented analysis, it's the conceptual idea, just something that is in your brain, you put it out and just focus on the definitions of how these things are going to work. But when you come to object-oriented design, it's more towards the actual implementation, how it is going to fit into the particular environment, how these business objects are going to work with each other. You go into detail. Okay, so object-oriented design includes the following main three activities: refining the use case model, modeling the class interactions behaviors that support the implementation environment. Right. So these are the three main things. First, you have to refine the use case to support the new environment. Then you so when we say refining, earlier we learned something called use case narratives. Use case narratives in the sense like you have a chart kind of a thing which defines for each use case you have a description. So you have to first update that document. After that, you have to update, you have to introduce more models, and you have to see which one is going to talk years. That is the second step. Then third would be, after getting this thing, the second part, you have to update your UML diagram last time. So first one, we'll again go through this briefly in the book itself. So first one, use cases will be refined to include details of how the actor will actually interface with the system and how the system will respond to that reaction to process the business event. So this is the first stage of OOAD. So define it to see how the actor is going to talk with the system. So if the actor is going to talk to interact with the system, what is the interface? So mostly it is going to focus on the entity classes and the interface classes. Then finally, how the system will respond to that reaction to process the business event. This is more focused on the control classes, where the business logic. So control classes and interface classes. So that part. And also sometimes, to some extent, the persistence class. Right. So the manner in which the user accesses the system should be described in detail. So you have to decide whether it is going through this particular interaction. You're going to use a menu. Are you going to use a button? Are you going to use a window? Whether it is going to be a, I don't know, like radio button, whatever the interface might be. Barcode reader, printer. So what is the interface the user is going to use to do that particular activity? So that is what we do. Instance of Windows queries and reports should be specified within the use case. So in this particular thing, when we start deciding this particular use case, for example, let's say we have chosen the window as the interface. So in our use case document, that narrative document, we have to define what is the window size, or whether it will have minimize button, whether it will have close button. Those kind of things. What is going to come inside that window? What is going to be shown? All those details should be. We don't have a chance again to come back to this. I mean, normally we do it at this stage. Refine. Okay. Then steps to adapt each use case to the implementation environment involves two steps, like transforming the analysis use case to design use case, then finally updating the use case model diagram. Okay, so this is again under the defining use case. So let me quickly go to this page. This is what we learned. So object-oriented design activities. So mostly there might be a part 2 question or a MCQ in this manner. Very easy to remember if you memorize this properly, or if you understand this properly. I would say rather than memorizing, it's better to understand. First stage in object-oriented design, refine the use case model to support the implementation environment or to reflect the implementation environment. Second, modeling the class interactions, new classes, new behaviors that support the previous step. Then finally, you have to update the diagram. Right. So under refining use case, let me quickly go through this. In the situation of use case modeling, the use cases will be refined to include details. I'm sorry, the printed version of this book is already a little bit cluttered. So You will have to manage with the letters here. In this iteration of use case building, use case will be defined to include details of how actor will laterally interface with the system and how the system will respond to that stimulus to process the business event. Okay? So mostly they're talking about that, as I mentioned. The manner in which the user accesses the system, as we in this note out of this one. So whether it is going to be a barcode reader, print, what type of hardware is going to use to do that business event. The kinds of those should be specified. While refining use cases, it is often time consuming and tedious. It is essential that they are completed. So when you're doing this refining process, it's going to be taking time. Obviously, when I'm explaining that, you might have, how are we going to do this? So this is not only one use case. Many use cases is going to interact. So for all of that, you have to specify this particular. You will have to specify the same pattern for each and every scenario, right? So it's going to be time consuming and tedious. Yes, it is essential that they are completed. These use cases sub new manuals and test this is in better to participation will be very helpful. In addition, these use cases will be used by the programmers, as I told, the development team, to construct the programs, application programs during system implementation. In the following steps, we will adapt each use case to the implementation environment or reality and document results. It is important that each use case be highly detailed in describing the user interaction with the system. This use case can be used by design and by the programmer for process because that refining thing is about. So in the refining process, we have two steps. Step one is transforming the analysis use case to the design use case. So here, so in our earlier lectures, we learned how we use basic use case modeling with a document. So generally, you will get a document like this. We notice with the use case name, who is the primary actor, who is the secondary actor, interested people, description, precondition, postcondition. All those things, we had it in the analysis use case narrative. Now, that is the same thing we are going to use to convert it into a design. Right. So what we do is in this step, we refine each of those use cases to reflect the physical aspects of the implementation environment for our new system. And we look at this example, this particular picture, I believe they're mentioning the refinement of the place new order use case that was originally defined during system analysis. This version is identified as a design use case that is to distinguish it from the analysis version previously completed. That means if you look at this document, sometimes you may feel what is different between that use case narrative and this one. So for that, they have highlighted certain things which differentiate this from that document. Now, if you look at this numbering 1, 2, 3, so the action, system response, there are certain things, not action, actually information. We'll go through these numbers here. All things might be the same thing that was there in the analysis use case, but here you might see there are more details on, for example, it's talking about particular window, what is the content that should be there, right, in the alternative process, like that. So they are mentioning about checkboxes. See the tools, whatever is inside that particular interface, what should be there. So how we see the differentiation, they have given it here. We draw your attention to the following refinements to our use case description. One different thing is the introduction of the use case type to reflect implementation details such as user interface, constraints, tactical use cases, called system design use cases are derived from the system analysis use case. So if you look at the number one use case type is mentioned, where you can make sure this is not a requirement, this is not an analysis thing, this is a design thing. So you have that one differentiation. Then use of interaction of window controls in a particular place or use case. Introduce window in system design use cases. Window controls such as icons, links, checkboxes, buttons are explicitly stated, right? So I think that is straightforward. So in our analysis use case, you won't see these words. So in this one, you will see that information, see icon, things like that. So that is one difference you will easily figure out that this is a design use case. Then you will have window names. The name of each user interface element is stated. If additional information about user interface element exists, it is good practice to reference it, and otherwise more detailed window specifications could be added to the use case. So in our example, you will see something like, for example, here, displaying window W11 catalog. Now we have this information, list of some such products to be displayed. But now you say where to display. You give the name of the window, right? So this is another indicator. This is a design use case. Similarly, navigation instruction, when somebody clicks on something, where to go, that level details will be there. You can even check that here. So, for example, the member scrolls through the available items by using the scroll bar buttons, page up and page down, and member selects one he or she wishes to purchase by clicking the checkbox and entering the code to. So you can see the clear instructions are also given. When this happens, what should happen and what needs to be clicked. That level detail you can find it in the refined use case, that is part of OOAD. So that is first step. Under refining use case, what we did is use case to define use cases. Second step, updating the use case model diagram and other documentation to reflect any new cases. Right. Now, after all these system analysis use cases have been transformed, it is quite possible that new use cases, new use case dependencies, or even actors have been discovered. It is very important that we keep our documentation accurate and current. So in this step, the use case model diagram, the use case dependency diagram, and the actor and the use case glossary should be updated to reflect any information introduced in step 1. So all these things need to be updated. When we say glossary, glossary means there might be a section in your diagram. So if you have introduced a new word, you have to give a meaning to that. You have to update it, keep that document updated. Right. So that was 655 pages. Then modeling class interactions, behaviors. So after the first stage, refining, now you have to model them. So in this modeling part, we do 3 things: identifying and classifying different use case design classes based on our use case scenario. Then so how do we identify new use case design classes? So in the previous section, we refined the use cases to reflect the implementation environment. In this activity, we want to identify and categorize the design classes required by the functionality in each use case, and identify the class interactions, their responsibilities and their behavior. Now, in our previous step, we saw an example for one particular use case, place new order. That example was place new order for the member registration system. Like that, consider all the use cases you have updated in the same way. So now you will find out there are new actions, new objects coming into the picture. Then in this stage, what we do is we introduce those new objects, new classes. So if there are new classes coming, new type of scenarios happening, you have to use whether it is going to be a controller class, whether it is an entity class, right? So those meanings are given here. For example, if it was those windows you are introducing, each window will come as an interface class. Then controller class for any new business rules. So you can give relevant names for those classes, meaningful names, and introduce them. So this is step 1 under modeling. Modeling the new class behaviors. So first step was to identify the new use case design classes. Second step is, if you sometimes the existing classes might have new attributes because of the refinement. So you have to update them. You have to update them. Or maybe you have to introduce new class attributes for the new classes. During both analysis and design, class attributes can be discovered in efforts to transform analysis use case into design use cases. We begin referencing the attributes in the use case text. In this step, we examine each use case and create our class diagram to include those attributes. So that's straightforward. Basically, new properties are there. You introduce those new properties. Okay. Whether it is a string, integer, anything, you can introduce. So the similar to attribute that is staying there alone. No? You have to make use of it. For that, you have to maybe introduce new methods, new behaviors, and responsibilities. So once we have identified all of it, some of the attention defining the specific behaviors and responsibilities. This step involves the following tasks. Right? Analyze the use cases to identify required system behaviors, associate behaviors and responsibilities with classes, model class behavior, examine the class diagram for additional behaviors, verify classifications, right? So all these things will need to be done to discover new class behaviors, new responsibilities, right? So in another way to relate these two to another simple analogy, let's say you didn't have a nose at the beginning when you were born or something. Suddenly the nose is introduced to your body. If you don't do anything with the nose, nose is there too. So if you don't have a responsibility associated with that attribute, then there's no point in having the attribute itself. Right? So similarly, in your classes, if you have discovered new attributes, that attribute cannot stay alone. It has to be made use of. So that's what we do in step 3. Not just by observing attributes, you have to also look at the other kind of interactions that are described in the refined use case in our field. Are you clear with this, with what I explained so far under this particular second major area in object-oriented design? So after refinement, we do modeling. So under modeling, we discuss 3 steps. First, to identify the new class and first class. Why is what imported in which area? Those also I have explained. Okay. No response yet. Okay, cool. So this is your thing in a paper or something when you do your refinement, right? So after your initial thing and then you have done your refinement, this is something you will do to do the step 1. The step 1, you might take a paper and then note down what are the interface classes available, what are the controller classes, what are the entity classes, what are the persistent classes, and any other system classes, etc. And then you will list down them as right? Then you will also categorize them whether it is going to be automated. So this is like a little bit advanced. Whether that particular methods inside, you will identify the different methods that are going to come under this, and you decide what are the whether it is going to be manual or automated. And then you decide this behavior under which one it is going to come, right? You will decide which one. So how do you extract these behaviors? You will read that. You will read those descriptions here in this area. This particular use case narrative we have now in our very first step. You will read these things and then list out all the behaviors that have come under a particular use case. Now, in this case, just for the place new order, you can see a lot of behaviors are there. Then you map them onto the relevant class types, whether it is going to be an interface, whether it's going to be an entity, like that. So this will be another document you will be prepared when you're doing a design. Okay. So we have learned that classes encapsulate data and behavior. Our first task in identifying the class behaviors and responsibilities is accomplished by once again examining our use case. The use case description to identify all verb phrases, as I told. So, and this we have to figure out with the verbs how we have used the verbs. Verb phrases suggest behaviors that are required to complete a use case. These verb phrases correlate with the behaviors required to correspond. So each use case like this, we have to repeat this for each of the use cases. So you will have a lot of set of documents information. And that will be easy for you then to come up with the updated UML diagram. So once the behaviors have been identified, our second task is to determine if the behaviors are manual or automated, as mentioned here. That you have to do. If they are to be automated, they must be assigned to the appropriate object that will have the responsibility of carrying out that behavior. So you have to map it to the type of object that is going to be doing it. So this list summarizes place, new order, use case behaviors. We have seen that. Third column is the object type with which each behavior is associated. That also explained. In figure 18.9, we have condensed the behaviors to show only the behaviors that need to be automated. Recall that the object types are defined earlier in step 1. Okay, we will use the listing to identify those of behaviors to be allocated in the So they are taking a sample out of the existing list and focused only on the automated areas and taken a summary of everything. Right. So once we have that summary list, the next task is to identify which behavior should be associated with which class and to identify collaborations among those classes. One popular tool for that is class responsibility collaboration card. Now, if I put a question on what are the tools to decide associated to which class in system design? This could be a typical question. What are the tools available to decide which behavior should be associated to which class? So we already saw in our first, our initial stage here. The second stage, we list out for each use case. So this is only one use case they have shown. For each use case, we read the description, we listed out the behaviors, decided whether they are automated or manual. This might be an optional step. Then we also map them to the relevant type of class. We haven't told which one is going to go under which class yet. We haven't done that. We just have simply told this is going to be a control type behavior. This is going to be an entity type. Map to the relevant class types we have already given as names. Right? Now we are going to basically merge those two steps together. We are going to so what is this here? As mentioned, class responsibility use to achieve this. One of the methods. So for example, the CRC card for the member order class is from figure 18.10. Okay, we'll see that down here. Right? So here you can see this is a typical CRC card for a particular class already identified. So object name, member order. There are any sub-objects. Sub-object means it has a super parent class. Mention that. And for this member order class, what are the objects? And if there are any covering objects, so maybe member or product in another class that might use the information from here, right? So this particular class has these objects and these behaviors and responsibilities. So you basically step this and so cards can be developed and refined using an iterative process. So this will always keep on changing, in which the cards are divided among a group of system analysts or users. They then move through the steps of a use case scenario, acting out the required collaboration. So using a spongy ball, the facilitator. So this is like a planning process that happens. You initiate discussion. So people in the design team will like play a game. So they have these cards and we exchange among members. Paper card they will go through and that will be updated. Right. So that's what they are explaining here. I'm not going to detail that. That is one thing. Okay. Analysis of the use case scenarios may not reveal all behaviors for any given object type. On the other hand, by examining the class diagram, you may find additional behaviors which are not mentioned in the use case scenario that need to be assigned to an object class. For example, in our refined use case, sometimes there might be certain information which are not directly mentioned, but when you are doing this association and mappings, you will find out that there are additional behaviors needed which are not described there, right? So in those cases, you can introduce those kind of new things into the class itself, which doesn't have to be part of the use case diagram, use case scenario, the description document itself. Right? So that's how we practically face certain issues. Then the other tool for discovering behaviors and responsibilities is to use a sequence diagram. So for the same question, sequence diagram is another tool. So sequence diagram, I think we haven't discussed in detail yet, but I think it's coming in the upcoming subjects. So sequence diagram will give another perspective of associating behaviors to certain objects. So basically, I think briefly we have also seen, but what is the sequence diagram? Sequence diagram looks something like this, right? You arrange all the entity classes, interface classes, controller classes, all these things in the top line, and then in a timed manner, you will see the order of the messages being passed or the calls being made. So you can see this is the first thing happening, then this is the second thing happening, third thing happening, and this is responding back after that what has happened, like that. In a timed manner, you can see top to bottom how the relationships between each entity. So when we put this information here, you can see we are directly putting the behavior names or the method names. Then looking at this, we can guess that now, for example, calculate quantity in stock. You're passing the product number. So this method should reside into the product object. Then only this place new order can call that person. So this should be a public method under product where this person can call. So through a sequence diagram also, you can achieve, you can identify this particular associations, which behavior is part of which class, by drawing a sequence diagram. So that might be the quickest way when you're doing a UML design diagram, rather than using a CRC card. So mostly CRC card method is suitable if you are in a big company and involved in a very large sensitive project, right? So in that case, maybe you will use the CRC tool before coming into the sequence diagram. Apart from that, if it's very small projects or things where you have to meet the deadlines very quickly, sequence diagram might be the best approach to discover the relationships and the class behaviors. Okay. So that information is given here related to the sequence diagram. Pencils here. So that was that information. Finally, updating the object model to reflect the implementation. So once you have figured out this CRC card and the sequence diagram, where you have identify all the objects, what are their behaviors, how those objects are going to talk to each other. Now you have to update in your properly in your UML. So once objects and other interaction have been designed, class diagram can be defined to represent software classes in the application. Design class diagram that depicts classes that correspond to software components that are used to build the software application. So that information we'll see here. 65. I will discuss this point in the next class. Further on how these design class diagrams are there and what information is available there. So basically, to revise what we do is, keep in mind object-oriented design has these main three activities involved. First one, refining the use case model to reflect the implementation environment. And must remember, one first point is transforming the analysis use case to the design use case. Under this one, refining use case model to reflect implementation environment. First step is transforming analysis use case to design use case. Then second step is to update the use case model diagram or use case dependency diagram. In this activity, you model the class instructions behaviors and steps. Basically, you decide what are the different class types that are involved. What are the new classes need to be introduced, and what are the new behaviors that are introduced, new attributes that are introduced, and how do you connect them with each other? How do you map them? So basically, we do the mapping. Right. So third activity which we haven't discussed yet is updating the class diagram to reflect the actual software implementation environment. So how do we overall update our unit? So this part I'll explain in the next class. With that, I conclude today's lecture. Any questions up to this point? Was it clear? Be clear if you revise this. How you understanding the other and doubts. Okay. Okay, no sir, yes sir. So what did you mean by no sir? I didn't get. Someone if plan. If I'm understanding you the wrong way, I don't know. All clear or no? Okay, so I'll give you this basically. Within today itself, you go through this, right? You go through this recording as every data recording edit version of this conversation going on, talking now, because something that might get delayed from YouTube because there is a connectivity issue from yesterday night. Even yesterday's the different lectures I couldn't upload. Only one I was able to upload. So within today itself, you just go through this so that this goes to your brains when you're fresh.